Okay, so today we're looking again at converting rational numbers between decimals and fractions. Just a quick reminder of what a rational number is. It's any number that can be written as a fraction. So any number that can be written as a fraction. So that's any number. So we summarize that as a over b because we know a can be any number and b can be any number. One thing to consider is that any decimal that terminates or repeats is going to be a rational number. So let's talk about converting decimals to fractions. Okay, so decimals to fractions. This can be done using the place value. That's important. We just look at the place value and we're good to go. The idea is just say it out loud, right? So just say it out loud. So if you have, let's say you have 0.75, right? Well, saying it as 0.75 is not quite as helpful as saying it as what it really is, which is 75 hundredths, which is pretty easy, right? You just write it 75 over 100 because 75 hundredths. And then what you need to do is make sure you simplify. It's pretty easy, right? So then you divide both the top and the bottom by 25. And we get that it's 3/4. Okay. And so, for instance, let's do this example here. You say 0.6, you say it out loud. It's not 0.6 as much as it is 6/10, right? 6/10, which we would write as 6 over 10, and simplify that, of course, becomes divide both the top and the bottom by 2. That's going to equal 3/5. All right. So let's just do a quick place value review. Don't forget that this is the tenths spot, the hundredths, the thousandths. Okay, well this is the thousandths, and then the 10,000ths. Oops. Okay, so let's look at some examples of those and just do them pretty quickly. So we've got 0.48, which we actually don't say that. How do we say that? Good, 48 hundredths. Simplify that. Both of those are divisible by 4. It becomes 12 over 25. So our next one. Now this one is a little bit easier because we can just say this as negative 3 and 5/10. So we don't even need to worry about the 3 because we can focus just on the 5/10 part. So it becomes negative 3 and 5/10. And we know 5/10 is 1/2. That's going to be a decimal to fraction conversion I'm going to want you to memorize. I'll show you at the end which fractions to conversion, which stuff we want to memorize. 0.11, which is not 0.11, it's hundredths, so 11 hundredths, and we're done. Oops. We're done. The question is why? Why are we done? Well, what do we know about 11 compared to 100? You're right, but there's no common factors. 11 is prime. So we can't simplify. Okay, so let's take a look at fractions to decimals now. This key only has one rule. The idea is just divide, right? Just divide. Yes, I know my face is a little creepy over there, but I'm divided in half. It's to help you remember. So once we have that, we've got a couple of ideas. There's two kinds of decimals. There's one called terminating, which you're going to want to fill in your notes. And those are decimals that stop. So 0.25, 25 hundredths, 4/10. Those are decimals that stop. The other kind of decimals are repeating decimals, and those are decimals that never end with a repeating pattern. Don't forget to use bar notation over the repeating digits only. So a good example of a repeating decimal is like 2/3, right? So that's going to be 0.6 repeating. Notice the bar is only over the repeating portion. So for example, notice when you have 0.45 repeating, the line is only over the 0.45, not 0.4545, right? Not like that. And similar here, notice how the 8 is not repeating, so there's no bar over the 8. The 3 is repeating, so the 3 gets the bar. Do a couple of examples. 3/5 going to fraction to decimal. The idea is there's two ways we can do this. I'm going to show you a shortcut way first, which I think is actually in your benefit. Notice how 5 is a factor of 10, which means we can scale 3/5 up to be something out of 10. So this is what I refer to as the easier method. And the idea here is that we can do this. 3/5, and we can multiply the top and the bottom, that's a 5 by the way, by 2. Now why is that helpful? Because now we have something that says 6/10. And we know what that is as a decimal, right? 6/10 is 0.6. So if you can get the denominator to be out of 100, out of 10, it makes it a lot easier. Now, don't forget, you can always use the simple method of division, right? Just divide, right? So you've got, come on, there we go. 3 divided by 5. And don't forget that decimal point. What is happening? There we go. So then 5 can't go into 3, but 5 can go into 36 times. Don't forget. Yep, you're good to go. So don't forget to add that decimal. That's going to be really important. Add that decimal. It's very, very important. Now, example 5 is a little bit trickier. The idea being here that this ends in an 11. And you might recall what I told you about 11s. Those are going to be repeating. So we're going to have to do our division. So 2 divided by 11, of course, is, there we go, 0. Something's going on with my computer and it's not working out. So there we go. Let me see what's going on. All right, I'm going to try this. I fixed it. 11 goes into 21 time. With a remainder of 9. Bring down that placeholder 0. 11 goes into 90. Come on. 11 goes into 98 times. So 88 with a remainder of 2. Bring down that placeholder 0, and I bet you're going to see where this is going to go. 1 time, 8 times, etc. Right? So it's going to be repeating. So the answer is going to be 0.18 repeating, right? Wrong. Don't forget your negative. Negative. Don't forget that. Last example here. When you read this one, it's 2 1/4, right? So I want you to just memorize this guy. Memorize this one. All right, so we've got negative, of course, 2 1/4. And why do I say it like that? Well, because 1/4 is a quarter. 25 cents is a quarter. 0.25 is also a quarter. Now we're going to look at ordering rationals, so putting them in order from least to greatest or greatest to least. To order a set of numbers, we must make them all fractions or all decimals. That's going to be important. So which is going to be easier in this case? I think it's typically easier to convert from fractions to decimals. There's less work involved. So I'm going to look at 2/5 and 2 divided by 5. That's 4. How many of you guys knew that one was going to be 4/10, right? 4/10. And then a quarter, we already did that one, negative 0.25, right? So as we look at these now, we take a look and we try to put them in order from least to greatest. First thing you want to do is make sure that you identify the positives and negatives. So we've got a negative here and a negative there. So those are the two possibilities. So we have to think which one is more negative. And 0.38, so 38 hundredths, that's more negative, which means that this one is going to be number 2. Now, careful, we want to put put the original numbers in the list, right? Not the converted decimals, put the original numbers in the list. So we've got negative 0.38, negative 1/4, not 0.25. And now we got to look and see which of these is the smallest. Well, to compare numbers, to compare decimals, you really only need to look at their common place values. So this one only has a place value of tenths, but keep in mind these are hundredths, right? So I need to actually think about this as 0.333 ... right? Not 0.3, but 0.3 repeating. That's important. 0.42 and 0.40. Now we can compare them a little bit easier. I don't need that one. So 0.33, 0.42, and 0.40. Now I can see them a little bit more clearly. 0.3 repeating. 0.40, which is 2/5 from the original list, and 0.42. Okay. That's all we're going to do on that one. One last slide. I want you to memorize these. These fraction to decimal conversions are going to be all over the place. You're going to run into them all the time. We've already talked about 1/4. That's 1/4, right? So 0.25. And this one, if you think about it as 2/4, right? If you think about it as 2/4, is 2/4. Or in other words, what? 50 cents. Good. So 0.5. That's one you probably already have memorized. 1/2 to 0.5. If you don't, get it memorized. This is not 3/4, it's 3/4. And how much money is 3/4? Good, 75 cents. Now the last two, you may know one of these. It's actually a little bit easier. Luckily, there's a bar over this 3. Do you see how there's a 1 bar 3? So if you kind of think about it like this, what's it kind of look like? Well, it kind of looks like it's decimal conversion, doesn't it? 1/3 is 0.3 repeating. And if we think about 2/3, I bet you can figure it out. I don't actually have to memorize 2/3 if I can remember 1/3 and how 2/3 relates to it. How does 2/3 relate to 1/3? Right, it's twice 1/3. So what's twice as big as 0.3 repeating? 0.6 repeating.